Alright, for this lesson, and actually for the next several lessons, we're going to be talking about some of the different shadow types that are available within 3ds Max. Alright, so this is the scene that we're going to be working with. Now, within 3ds Max, we actually have a couple of different shadow types to choose from. So to see those, let's go ahead and create a standard light. And we can just use a omnidirectional light. So let's go ahead and just drop this into the scene. And pick this up and move it where we need to. Alright, any place should work. Really doesn't need to be any place in particular. So let's maybe actually bring this around, maybe to the back side, just so we can actually see some of these shadows being cast backward. Alright, now to enable shadows on a light, it's really pretty straightforward. Just go to the Modify panel, and we're going to scroll down to the General Parameters. It's going to be right underneath Shadows. We can turn this on. Now once that's enabled, we can choose from some of these different shadow types. So one is a shadow map, and that's the one that we're going to talk about for this lesson. And then we also have some of these other versions of these different shadows, and we'll talk about these throughout the course of the next couple of lessons. So let's start with the shadow map. Now the shadow map is one of the most basic types of shadows available within 3ds Max. It really kind of has some trade-offs to it. There's some pros and cons to it. Number one, a shadow map renders very quickly. So you'll see as I step in and take a render, this really renders out very quickly. Now one thing that I do need to do is turn off my logarithmic exposure. This is one thing that I had left turned on from our previous lesson. There we go. Alright, so you can see the good thing about these depth map shadows is that they actually render out very, very quickly. We've added really almost no render time whatsoever to our scene by adding these depth map shadows. Now the downside is that really don't look so great at first. So you can see that they're very noisy, kind of splotchy, not very accurate, and that's kind of the downfall of these shadow maps. So what we can do is let's come back and start by maybe taking this light and pulling this back just a little bit, just so we can get a little bit more light back in here. Alright, that way we don't get quite so much of a dark shadow from this actual shelf. Now one thing that we actually can do is view these maps here within the viewport. So if I have a light selected, I can just right click on it, go to Viewport, Lighting and Shadows, and let's enable Viewport Shadows for selected lights. Alright, now at first we're not going to get any kind of a result, so we also need to go back to our Viewport, Lighting and Shading, and then make sure that we also have our Viewport Shading set to Best. There we go. And now we can actually see what these depth map shadows are going to look like inside the viewport. So as I pick up my light and move it around, we can actually see these shadows in real time. So it really kind of gives us a very quick and easy way of getting an idea of where our shadows are going to fall without actually having to take the time to re-render anything. Alright, so we can just quickly compare this to what we have. And you can see it's pretty close. Obviously not 100% identical, but close enough to get an idea of where your shadows are going to be. So this shadow map, it really is kind of doing what its name suggests. It's actually generating a map that is then overlaid on top of your render to create the effect of these shadows. Now we can actually control a lot of different aspects of this if we go to the shadow map parameters. So we have the shadow parameters, which is right up above that in the rollout. This is where we can control the shadow color and the density. So pretty straightforward. If we needed our shadows to have some kind of coloration to them, we can actually see that right in here. All right, and then also we have the shadow density, which is the overall opacity of your shadows. So if you need just really, really faint shadows, you can dial that intensity way down, or give them full opacity with a value of 1. Alright, now the rollout just below that, the shadow map parameters. This is what we're going to talk about for the next little bit in this lesson. So what it's actually doing is generating a map that's 512 pixels by 512 pixels, and then actually overlaying that on top of our render to create the effect of these shadows. Now if we want to get our shadows to be a little bit softer, we could do one of two things. A very quick and easy thing that you can do is actually take this shadow map size and drop this down. So if I cut this down to, let's say, 128 pixel image, a couple of things will happen. Your renders should, number one, happen even faster, but number two, because you're taking a smaller image and still spacing it out and overlaying it on top of your render, you're now forcing that to be a little bit fuzzier and a little bit softer. So, quick and easy way to get these soft shadows. Now, likewise, if we wanted to get sharper, more defined shadows, we would start to increase this. Now, you'll also notice that as you start to increase this, your renders will start to take a little bit longer because it's generating a more defined map, a little higher resolution map. And one thing that you also probably notice is that we have sort of these weird little spacing areas that are right underneath areas like the saucer and underneath the cup. Now that is having to do with this bias setting. So what this bias does is it will basically say any objects that distance-wise are closer than whatever this bias distance is, do not cast any shadows in that area. So it just kind of helps speed things along if you've got a lot of things really close together and you don't necessarily need to generate very detailed shadow maps in those areas. You can kick up this bias and kind of save some of your computation. Now normally I find this bias to be kicked up a little bit too high, so I almost always find myself having to take this back down to some kind of a lower value. And what you should see is as we start to lower this, now it fills in some of those kind of spaced out gap type areas. Alright, and then finally we have the sample range, which is controlling the number of pixels across which these actual maps that are generated are going to be kind of spaced out or kind of blurred across. So with a sample range of 0, what we should see is almost no softening of these shadow maps, and this becomes probably a little bit more apparent as we actually lower the size so you could see the individual pixels of this shadow map. Alright, so as we start to increase the sample range, let's say from a value of 4 to a value of 10, we should force this to actually soften and blur out even more. You can see that's exactly the effect that we get. So if you're using a little bit higher resolution map, and you need to be able to get kind of a combination of a fairly high amount of detail plus a decent amount of softness, you can start to take up this map size and then start to bump up the sample range. Alright, so now one of the things that you'll also notice is while these shadow maps or these depth map shadows are relatively quick to render and they work good for solid objects, they do have one major downfall, and that becomes very apparent as you take a look at this pen holder. Now, if I were to render this out, you'll notice that these shadow maps do not take transparency into account. You'll see that we actually have sort of this wireframe mesh around this pen holder, so we should actually be getting some transparency through those areas of the wires in here, and that's actually not what we're getting. Now, if this were actual geometry that was modeled into this shape, we would probably get that effect, but we're actually using just a solid tube that has a transparency map applied to it, and that's why we're losing this effect whenever we use this depth map shadow or this shadow map. So what we'll do in the next lesson is take a look at another shadow method that will actually let us calculate this transparency map.